Welcome to another procedural texturing tutorial. In this one we will be building on the group that we made last time, the shapes group that allowed us to output circles, squares, triangles and hearts. This time we will be bringing it together with this shape tiles group node that allows us to work in an infinite amount of tiles. It will randomly distribute our shapes, and it will also allow us to control random color, rotation and scale. Change the shape's color, the color of the grout, and the color of the background, controlling the size of our shapes, thickness of the grout. We also have a random seed on the outside. A lot of what we're talking about today is super transferable. We're talking about tiling, we're talking about randomness, all very important things for procedural textures and just manipulating textures in general. So I hope you learned something, I hope you enjoy it. Let's get stuck in. To get started, I'm working in Blender 2.82 and we're going to make sure that our node wrangler add-on is enabled. I have a workspace here set up. I like to have a material shader editor on my right hand side, and just so that I can see my output, I have a 3D viewport. So create a new material. We're going to be working with our texture coordinate node. Everything once again is based on our texture coordinates. Going to be working with object coordinates. Shift tab turns on snapping to grid, and just then to remove the unused node sockets, that was Control H. The first thing I'm going to want to sort out is how we do our grid lines. Now, in order to scale up our space, I can do it one of two ways. We can use a vector math node here, and we can set this to be multiply, and we can increase the size of all of these. A quicker way, rather than typing in the number and clicking on the next one or pressing tab to go to the next one, we can select them all together and click and drag. That's one way. The great thing about doing it this way, this will keep differences. So let's say you have three different numbers and you want them to move while maintaining the same difference. You can do that. If you would like to just select them all, then I'll make them the same, or select them all and type in a number and it will type the number into all of those. Now, rather than using the multiply node, I'm actually going to be using scale. Scale does the same thing. And change our scale to 3. So now we have -3, 2, 1, 0, and then positive 1, 2, and 3 in both axes. Remember, this is happening in a vector math node, so it's affecting all of the axes together. The next thing we're going to do is we're going to duplicate our vector math node, drop it on again, and we're going to change this from scale to fraction. And this has given us just a simple 1x1 square with values 0 to 1 on each axis. Now, a lot of people preference modulo over fraction, so let's have a look at that one. If I change all of these to be 1, you'll notice that in the positive space we have the same as the fraction node. However, in the negative space, the modulo node is not showing anything. It's not because there's nothing there, it's just because those values are below 0. Fraction is flawed division, which means that it is always working away from negative infinity, and modulo is truncated division, which means it's working away from 0. Now, the benefit of using modulo, you can increase the point at which modulo modulates at, and that is not something that you can do with fraction. Fraction is always modulating at 1, 0 to 1. Because it's computationally cheaper, I'm going to use fraction. Now, what I'm going to do is I'm going to add a converter, separate x, y, z, and I'm going to add a math node and set this to be greater than. Greater than provides a binary output based around your second value. So the input compared against the second value. Is this greater than this second value? Yes will result in an output of 1, no will result in an output of 0. This is just a Boolean operation. And when you have a simple linear gradient like this, greater than works quite predictably. I'm going to duplicate this and I'm going to put this onto the y-axis so that we have both of these here. I'm then going to duplicate it a third time, but I'm going to set it to multiply, and I'm just going to drop that into that node together. We have different controls for our x and our y. I would like the same control. I'm going to add an input value. I can just plug into the bottom of both. So now I have a single value going into both of those, and that'll do that. Now, you might notice that our tiles are shrinking, but they're only shrinking in one direction. This is not how we want these to behave. We want all of our tiles to be shrinking symmetrically. So in order to do that, rather than having it go from 0 to 1, 0 to 1, we want it to go from 0 to 1 to 0, 0 to 1 to 0. So our gradients become symmetrical across each of our tiles here. I'm just going to add a color ramp, click the plus button button on here to add a third flag. This position default to halfway between the two flags. Set the value of this to 1. I'm going to set the final flag value to 0. And now if I plug the X into this, you can see that it has been remapped to be 0, 1, 0, 1, 0. Take this into our greater than node, and you're going to duplicate this. I'm going to drop this onto the Y-axis as well. Now if we have a look at our multiply, when we change this, all of our lines expand and contract symmetrically. I'm going to select everything, Control J, press N. I'm going to rename this ground. Now in the last lesson, we made a group node that created shapes, circles, squares, triangles, and hearts. I want to use that for this material. But if I go Shift A and I look in my groups, I haven't got it, what I need to do is I need to append it. I'm going to go File, Append. So when you append something, you're going to need to look inside a blend file. If you navigate to where you saved your shapes, inside that file, you'll be able to see that we have a whole load of different folders. What we're looking for is node tree. In here, we can see that we've got one called shapes. If we add that, nothing's happened. But when we go Shift A group, we can now see that shapes is in here. So taking object coordinates into the vector, we have a size and we have a fall off adjustment. We have circles, squares, triangles, and hearts. Our input needs to have a 0, 0 point. All of our shapes are designed to sit on that 0, 0 point. So with object coordinates, that's fine, it's in the middle. However, we want each one of our tiles to have those axes so that we can put a circle in each one. Using those that we've already increased the scale by 3 times, and we've put it through a fraction node, which split this into individual UV spaces. We want 0, 0 to be at the center of each space. If we just take this and we plug the vector output into the vector input of our shapes group, you can see that all of our shapes sit on the corner. We would like to move this up so that we have not 0.5 in the middle, but just 0. If we take the mapping node and we plug it in here, you can see that if we change the location and we change the location to minus, then our object is going in a positive direction. This is because we are affecting the UV space. That is controlled by this type point. We are going to change type to texture. Now, if you move the location, positive values result in a positive translation of our texture, not the UV points, but the texture. So if we set this to 0.5, 0.5, and we're just going to reduce the size, we do not want to move the Z value because we are working with length in our shapes. We have our circle is using length and our hearts are using length. We do not want to be affecting this Z value because it's essentially moving our sphere, our length, vertically, and we are texturing a plane. So we are taking our shape out of the dimension that we are able to work with. Think about our plane, looks like this, and we have a sphere. So as this moves up or down, we get different sizes as it comes in or out. So we're going to leave that at 0, that's quite important. A lot of the material that we're making is looking at how we can bring randomness into our materials. So to do this, we need a random value for every single tile to get randomness with all of the tiles. It's actually really simple to do with Blender. Rather than using our fraction here, I'm just going to do Control Shift D to duplicate with our input noodle here. I'm going to change this from fraction to snap. I'm going to change the snap value to 1. We want our snap tiles to be the same size. What snap has just done is it has snapped every value to the integer below, where we have a graph where the value over x, so that's what our scale input looks like. This is a value here of 3, which is what we have here. When we snap it, what we actually then get, as soon as it reaches 3, it would become 3, but we don't see any of that. We're not going beyond it, so we can say here that the value is greater than or equal to the value, where it is also less than the value plus 1. 0 until it reaches 1, it is 0. So that's why we use snap, because we get a continuous value per tile. We need to convert that continuous value into a random value, and to do that we can either use the noise texture or we can use the white noise texture. If I put these onto our unsnapped coordinates, then you can see that our noise texture, this is random, but it's sort of regions of random, whereas the white noise texture, you almost can't see it, but it's every pixel. Why it doesn't change when you zoom in or zoom out, it's only at a pixel level because it's controlled by the input vector. So every change in input vector results in a different value being produced. With the scale, this value changes at every single pixel, but once we've snapped it, then we're getting a single vector per cell. So then when we put that through the white noise texture, we get this pixelized look. We're going to change from 3D to 4D because I want this W. W is going to give us a seed value that allows us to change the random distribution, and then once we've done that, we can start looking at how we can integrate this into our shapes. So to start with, let's have a look at how it can change scale. So as we change the seed, we randomly change the scaling. So where we have a lower value, then the size of our shape becomes considerably smaller. Where the value is closer to 1, the scale is closer to 1, and therefore the shape remains a similar size to what it was before. I want this to be variable. I want to be able to say, yes, random scale, no random scale. And I want that to be on a sliding scale. So what I'm going to do is I'm going to say color mix RGB. Now what we have is we have a mix, and the default value here is not 1. If I set that to be white, then we'll have standard scale or some amount of that randomness. At the moment we have 0 resulting in lots of randomness and 1 resulting in no randomness. And I actually want the opposite effect. So now what we have is no randomness and yes randomness. So great, that's our random scaling. The next one I'm going to do is random rotation. We want to be able to rotate the Z axis. What we can see on here is that we have a value in degrees. We only want to be able to affect the Z. We need something that will let us use a single stream of information, combine XYZ, factor into rotation. Now we can put something into this Z. What I just said about this being in degrees, if I use a combine XYZ, this is now actually in radians. So that's something that you really need to be aware of, is that generally speaking, unless it states otherwise, you're working in radians. We can plug this white noise into our Z here. And I'm just going to do Control H. Now we have a random rotation. I'm just going to duplicate our mix and I'm going to drop that on. I'm going to plug this into the second socket, and now rather than it going from 1, which gives us this slight offset, we're going to set that to be black so that there is no rotation. When we increase the rotation, you can see that they all rotate counterclockwise, and the maximum rotation is only actually very slight. It's not going that far at all. That is because we have a value range of 0 to 1, whereas a full circle has a range of 2 pi. We therefore want to multiply our output by 2 times pi. So now you can see that we get a full 360 degrees of variation. However, all of our shapes are also going counterclockwise. I would like them to be rotating clockwise as well as counterclockwise. So rather than it going from a range of 0 to 2 pi, I would like it to go from negative pi to positive pi. To do this, we just need to subtract pi. 2 ways to do this. I can either duplicate the maths node, set this to subtract, and put pi in this input. So now we can see that we're getting opposing rotation, which is great. That is what we want. However, there is a quicker way to do this rather than using the subtract here. I'm going to change this from multiply to multiply add, and I'm going to set this value to minus pi. So now we are multiplying by 2 pi, subtracting pi on the single node, and that's doing exactly what we wanted to. So now what we have is random rotation, random scaling, and we have controls for both. One of the big reasons that we're using 4D noise, which has the access to the seed, is it will allow us to make sure that we're not using the same seed value for different transformations. At the moment, things that rotate a lot are also the largest, and things that rotate a lot in a clockwise direction are the smallest. Even though we're working with randomness, what we have is a pattern. So to change this, I'm going to duplicate our white noise node, and I'm just going to use that one instead for our rotation. And now what I need to make sure is that instead of having the same seed value, that I have a different seed value. Any value is fine. So let's use 0 and 1. So now we have different randomness between the two different transforms. In order for us to do the next part, which is randomly distributing our 4 shapes across the tiles, we need to make something called a gate. To make our gate, we need to have a system that will allow us to have 4 inputs and 1 output, and distribute those 4 inputs according to some seed value, some random input. So you can see where this is going. We're going to get another white noise node. I'm going to change the seed of this one to 2, just so that we have different value. And we are going to just be using mixed nodes in order to distribute our 4 shapes according to the rules set out by our noise texture. I'm going to duplicate our mix here, and you will notice that we have a factor. This factor will allow us to flip between 0 and 1. So if we have 4 sockets, then we need to be able to switch between 0 and 1 on each of them, but we also need to connect them. So I'm going to have to use another mix node here. Now we need mix 1 here to go from 0 to 1. We then need mix 3 here to go from 0 to 1. And then we need this one to go from 0 to 1. If you were to have a larger system with 6 inputs, for example, then you would need to have another input here that would go 0 to 1, 0 to 1, 0 to 1, 0 to 1, 0 to 1. So that's your order. You can add branches and add branches and add branches. We next need to have a range of numbers from 0 to 1, 1 to 2, and 2, 3. In order for us to do that, when we've only got 0 to 1, if you remember what we did with snapping, when we have a scale of 4, then we have 0, 1, 2, 3. And so we're going to take our noise texture, we're going to add a converter math node, multiply by 4. We're then going to add another math node after that, and we're going to change this to snap, and change the snapping value to be 1. So now we have values of 0, 1, 2, and 3. Now, if we just plug this straight into our mix here, what we've got is some values, which are 0, and other values, which are 1, 2, and 3. They will just show up as 1. We then need to mix this second one with all of the values, which are 2 and 3. So we're adding 2 and 3 here. So to do this, we branch off from this snap node, and we subtract 1. So what this has done is we always need 0 to 1. So to get the relevant 0 to 1, I have just shifted this down. I'm then going to do the same again, and I'm going to change this to 2. So this time we'll shift it down 2 steps, and I'm just putting that in there. I'm just going to group this together, and I'm going to call it gate. I'm going to be using color inputs, and I'm also going to be using a color output. There is also going to be a seed input, which is just a single line of information. So we have this value input. I'm going to rename that to seed, and then I'm going to connect our 4 different color inputs here. And I'm going to rename this 1, 2, 3, and 4. And our output, I'm just going to rename that to output. So great, we have our seed. That goes into our seed value. And now if we plug in our circles, our squares, our triangles, and our hearts, now we have randomly distributed our shapes. They are all connected to the size and fall off. And if we change our seed value, then it will change the distribution of those shapes. All of the scaling still affects all of them, and all of the rotation still affects all of them. The final thing that I want to be able to do to these shapes is I want to be able to distribute colors across them at random. I'm going to duplicate our final white noise here. I'm going to do Control-Shift-D so that it brings the noodle, and I'm going to change the seed to be 3 just so that we have another different seed. I'm going to add a color hue saturation. Now, for us to be able to randomly assign colors, we need to have a base color, which we can see here. And if we move the hue, we can shift it up to 1 or down to 0. Starting at 0.5, we have values from 0 to 1. What we can do now is if we plug this onto our hue, you can see that we get a change in here, but we have lots more than 4 colors. In order for us to snap this to be 4, we can go convert math snap, and rather than 0.5, we can change that to 0.25. This will give us 4 sections, which it is snapping to. The great thing about this hue saturation value is that we already have our factor right on the node, so we don't need to do anything like we did before with the mix. What we can do now to join everything together is we can add a mix RGB. We have an indexed list with mix RGBs. If I plug the output, our shape output, into our factor, then we have a background color, which is in 2, and we have a foreground color, our shape color, which is in 1. This is because we have black shapes index 0, and we have white background index 1. Now we can take our color, put that onto our shapes. We have a control for the background color, and we have our input control the shapes and the factor on the randomness. Following that, we need another mix RGB. This, we are going to add in our original grout grid, and we're going to use this as a factor. In this case, we have black lines and we have white tiles. So when that goes onto the mix node, we have our lines being the first option, and we have our tile color being the second option, which we can take from the previous mix. Let's make a couple of little tweaks to our shapes one, because as you can see, this rotated heart, this rotated triangle, these are not centered. So we can just affect very easily. We can add a converter, vector math, and I'm going to drop the Y value a little bit just to move it up slightly, 0.07, and I'm going to do the same for the heart, in this case to a positive value of 0.1. Don't want to go too far. That's made that slight adjustment. Final thing for us to do, we're going to turn this into a group. Select everything, Control G, and we'll bring up our information panel. Now I want several outputs. We have our current output. This I'm just going to rename to tiles complete. I then also want my shapes. This is how they come out, but because they're black and white, I don't really want that to be a yellow output, so I'm going to delete that. I'm going to take any grey output and attach it, and then going to replace that with the one that we want. Rename this shapes. I'm also going to add the grout output, and lastly I'm going to add just one of the random values. On the outside of our node we have tiles complete, which gives us our full tile. We have our shapes, which gives us our black and white mask. We have our grout, which gives us our grout mask, and we have a random value per cell. I'm just going to rename this node group to be shape tiles. Now we need to think about our inputs. I like to have my coordinates on the outside. Control H to hide. We need to make an input on our group input. I'm just going to drop that across coordinates. Then I'm just going to go through this node tree and I'm going to add where I want there to be a controllable input from the outside. If I just connect this object into here, that'll bring us back. I can delete this. I'm going to connect this scale here and I'm going to rename this tiling. I'm going to add size and I'm going to add fall off. Just like how we did before, I'm going to change the default value to 0.5 and the fall off 0.95. The next one of our inputs we're going to do is our background color. What we can see on here is this sort of peachy color, which we can find here on this mix node. I'm just going to connect that up, and if we look at this, I might just make it whiter and desaturate it, leave it as an actual white. Rename to background color. The next input I want is grout color, which is this pink here. Final color input is our main shape color. Then I'm going to have the sliders for the randomness. Connect the next one to the factor of the hue saturation value, color rand. One after that's going to be scale randomness. Connect this to the factor of our scale randomness. Next one will be our factor of the rotation rand, and then our last two are going to be our grout thickness, which was this value up here. And instead of connecting to both of these, I'm going to go shift right click and drag across. This is going to create a reroute. I'm just going to delete this value. I know that the greater than wants to be a sliding scale between 0 and 1. We can get the slide from a factor. So I'm just going to take this transparent socket, I'm going to plug it into any factor that I can find, and I'm going to reconnect my rotation randomness to that socket. So now what I've got is I've got a sliding factor, and I'm going to call this one grout thickness. I'm also going to reduce the default value to 0.1. Grout thickness can now connect to that reroute, and here we go. So now what I've got is a slide to the grout thickness. It may even make more sense to put the grout thickness higher up in between the tiling and the size. If we wanted to move our grout thickness, we can't click and drag, but we can make sure it is selected and press the up button until it is in the position that we want it to be. Finally, we want to have a control for our seeds, just so that we can change them rather than just plugging straight in from this W, which I'm going to rename as seed, rather than just plugging this into all of them, which will result in the same distribution. So all of my squares are pink, all of my triangles are oranges, all of my hearts are green, my circles are blue. Not really what I was wanting it to be. So that's why it's important that we use different seed values. Very easy for us to do that though. The first one is fine. We're going to add a converter, a math node, just add 1, 2, 3. And now our seed values are all different. So now we've made our second group node. It should show up on our list here. We also still have access to our gate, and I'll show you a little extra tip for the gate momentarily. So I know that the material that we've made today is less realistic. It's not about creating red bricks or creating roofing tiles or things like that. It's important to get the understanding of manipulating UV coordinates to do your bidding. I hope it's been informative, and I hope you've enjoyed it and learned something, and I hope you'll join me next time as well, where we are going to be looking at something slightly more advanced, just one step above, before we get into doing real materials, just to get our foundations down with procedural textures. Okay, thanks for tuning in, hope you've enjoyed, and I will catch you next time. So I said that I would show you a little something that you can do with the gate. Working in cycles allows you to use a function on the geometry node called random per island. So I have two arrays on this one plane, and random per island lets you set a random value per geometry island. There is an object random. This works with cycles and with Eevee, but it will only work on disconnected objects. So it does not work with arrays. So random per island, I've got 4 different plywood textures. These are photo textures, so they're quite high quality, but as you can see, if every single one looked like this, it's got a very clear pattern. Let's take our random per island, which is a random value between 0 and 1, pass it through our gate. You can see where this is going. Then we can just pass all of our textures through. And there we go. You have randomly distributed your image textures across an array.